Hello everyone, we'll go back to Geography 113. This is a short tutorial on projections, datums, and transformations in ArcGIS Pro. So I'm just going to be going over a review of the project tool and the define project tool. You should have already used this at least once or twice in previous geography classes, Geography 11 and Geography 12, but if not, then this will be a good time to go over that, okay? So I just want to point out that after you download the data from the review tutorial for California counties, you're going to get this zipped file. So extract the California counties that you find in there, okay? And put them in a Lab 2 tutorial or some type of folder for you. And then open ArcGIS Pro. And when you open ArcGIS Pro, we're going to create a new project. So let's navigate then to this Lab 2 folder. You see, so there's nothing here. So I'm going to select this, and then I'm going to select Lab 2 as the place to save my project, and I'm just going to save this projections or something like that, right? So once you create this, I want to bring your attention to a few components of the software. Okay, so we have created our new projections folder within the Lab 2, right? So as you can see here, if we trace the path, it's in my desktop. It's called Lab 2, and this is the projections ArcGIS project. Okay. So let's look into projections and coordinate systems. We already looked at these a few weeks ago in a lecture, but you can find the projection of your map by going to the properties, okay? But before we do that, let me just zoom out so that you see what kind of map we're working with, right? So the default is going to be this web Mercator for a lot of projects, and you can see it's a Mercator because of the exaggeration of the North and the South Pole. In this projection, right? So if we go and look at properties, we see here under coordinate systems, right, that we have the WGS 1984 Web Mercator Auxiliary Sphere. And so the Web Mercator is a default for a lot of online projects, okay? So once you add a layer here, however, then the default projection of the map is going to also switch to whichever top layer you add here at the top, okay? So here, for example, if we look at layers, our layers are currently using the Web Mercator, and so that's what we are grabbing for this, okay? So whenever we open the coordinate systems folder through our map layout, we see that we have what are known as geographic coordinate systems and projected coordinate systems. So just to review, the geographic coordinate systems are basically what we refer to as the datums. So the datums for North America that we have looked at, for example, are, if we look at, if we expand the geographic coordinate system or the GCS, we look into North America, and we're going to find USA and territories, and this is where we find our NAD, North American datum of 1983, North American datum of 1927, along with others for the US and territories. Puerto Rico, for example, and Hawaii also have their own datums, okay? In addition to this North America datum, we also have, for example, under the world GCS, we're going to also find our WGS 1984 in different variations. I recommend that if you work in a few projects, for example, for this class, we are in the United States, so we're going to be working with North American datums. What I recommend that you do is that you save to your favorites some of these datums because you're going to be using them often. So if I worked in Mexico, I would probably have the Mexican datum saved, right? And what you can see here in my favorites, I have the California state plane for This is for Southern California under the NAD. We also have the state plane for Texas, which we have been using in our Olander tutorials. We also have the Albers equal area conic. This is also a projected coordinate system that I like to use to display the United States. The equal Earth is a projection I like to use to display the whole planet. And we also have the UTM zone, the Universal Transverse Mercator projection zones 11N. So that's going to be for this is the zone where you find California as well. And lastly, the WGS84 Web Mercator, which is one of the most common for online mapping, right? So I recommend that you begin to get familiar with the projections that you use constantly and add them to your favorites if you don't have them already, okay? So there's a few tools that we use when we are identifying the projections, so we'll go over those in a minute. But again, just to recap, the GCS, Geographic Coordinate System, these are basically coordinate systems that use angular units, and these are for spherical representations of the Earth. Whereas the projected coordinate system, this is for flat projections of the Earth. When we do a projected coordinate system, we are when we use a projected coordinate system, we also find, for example, the Universal Transverse Mercator for the North America, right? This is going to have our different UTM zones for North America. If you recall, the UTM projection it's a flat rectangular map of the world. We also have other continental projections. So for North America, one of the most common is the North America Albers equal area conic projection. We use a conic projection. Equal area is ideal when we're doing thematic mapping in North America, and the conic projection is ideal for northern latitudes like Europe, the United States, Russia, China as well. Let's see, which other projections did I want to share with you here? Let me take a look. Okay, let's continue exploring some of the projected coordinate systems. So projected coordinate systems are a display of the Earth on a flat surface. So we already looked at the favorites. So in terms of the projected coordinate systems, as I mentioned, here you're going to find your Universal Transverse Mercator, but you're also going to find different world projections. So if you have asked yourself in the past, where is that one specific projection, right? So here, for example, we find the equal Earth projection, which is an update for world projections. So here we can see the distortions of the Mercator in the north and south poles. The equal Earth projection is a new projection for global data that tries to avoid these distortions in the north and the south pole. In addition to this projection, here at the projected coordinate systems, when we go to the world, again, we find other projections that are very interesting, like the Bond projection for the world. I believe it's called Bond or Boon. And this gives us the world in a heart shape as well, right? So this could be used for example, advertisement purposes. If you are making a thematic map about Valentine's Day around the world, or expenditures on dinners and dates, right? Something thematic to do with couples or Valentine's Day. So different projections could also align to your thematic maps. Let's look at this one for cube. I haven't tried that one before. Let's see what it looks like. Okay, so the world is connected, and there's a few areas that are distorted. Got it. So this is for us to print out and print a cube of the world. Let's look at a few more of these projections. So another common one that we use for to display the whole world is so of course the default Mercator projection, right? let's see, the Robinson is similar to the equal Earth projection as well. There's not a lot of big differences except that the equal Earth tries to be more responsible when it comes to the display of the North and South Pole, or not responsible, but rather have less distortion there. And in comparison, Greenland still looks quite large in the Robinson projection. Okay, and we could use the Van der Grinten as well. Let me just use the Winkle triple as the last one. The Winkle triple is a common projection that is used in National Geographic, for example, right? And there's also the World from Space, which is another of these projections. We'll try that one in a minute, okay? So I'm just using this here to show you that there are many of the projections that you often want to look at are going to be in the projected coordinate systems. For now, let's return to the default, which is the Web Mercator. So for this lab, I'm going to ask you to add the data once you have moved the California, once you have created your project file and once you have moved the California counties into that shape file, into this folder, we're going to begin to add some of that data, okay? So let me add a connection to the folder. Oh, excuse me. Let me. Sure, you could add a folder. I'm just going to go ahead and add the data from that Lab2 folder for California counties. So let me go to my computer, my desktop, right, and then this is Lab2. And I'm going to go ahead and add California counties. Note that you are not going to have the U.S. state plane. That is for another example I'm going to do in a minute. But this is for the California counties, Tiger 2016. That's the file that you should have downloaded. So let's add it. And immediately, right, the file is going to show up here in California. The map is going to center on it. So let's take a look and see what projection or coordinate system we have here. Let's go to source. Let's look at spatial reference. And so the projection for the rest of the world is still the Mercator projection. Oops, apologies, right? So let me the Mercator projection is still the way that we're displaying the world. And when you use a Mercator projection, California is going to appear in this specific display, right? If we change the projection for this data, we can go to its properties again. We can see its reference. So we have here our datum that we are using for this data is, or the geographic coordinate system is WGS84, okay? So I want you to note that if you are using data that does not require all data requires a coordinate system, okay? However, some data only has a geographic coordinate system, which is what we refer to as a datum. That is the reference that could be a local datum to Texas, for example, right? However, if you are going to use a projected coordinate system, that projected coordinate system usually does have a datum to define it as well, a GCS, okay? So in this case, our data is in WGS 1984. And our map is using, our display is using the projection of the Web Mercator, okay? This is one way to display California, we could say relatively accurately. However, if there's a few other projections that we could use for California. So for example, let's change the map projection for California and do projected coordinate systems, the UTM. Oh, I already have my UTM zones up here, so let's find under projected coordinate systems, let's find the WGS84 UTM zone 11N. So I'm going to show you that California then becomes slightly slanted. And when we zoom out, we see this emphasis, right, this central UTM zone, which is different than what we had before, right? And so let me go back to the previous projection, which was the Mercator, right? So that should take us back to undo the properties. Let's see. Okay, it's not going back, so I would have to come back and change it here. Well, we'll leave it. We'll leave it instead of going back to the Mercator. Let me just show you then how California would look with the U.S. Albert equal area conic. So this I usually don't recommend the Albert equal area conic because the state can look a bit slanted, but it depends on your display. It depends on the once you start to work with your layout, the layout might make more sense for California to be displayed with a slight slant. Okay, let's zoom out to the world and see what this conic projection looks like. So you can see here why we prefer this for North America. If we are displaying the whole United States, we can see the curvature of the country a lot better than if we leave it in the, let's go back to the auxiliary Mercator, right? We also have a common way of displaying the United States. However, we don't think that this is as accurate for area that is thematic because it stretches the states here in the northern portion of the country because this projection distorts the northern latitudes, okay? So if we're going to be displaying data for the whole United States, we would do so with the Albers equal area. If we're going to display data for California, we could also use the state plane coordinate system, right? And because this is UTM, or no, let's take a look. The California, let's see what we're doing here. The state plane coordinate system using NAD 1983, okay? The North American datum, 1983, and this is the state plane projection. So let's see what California would look with the equal Earth. So here with the equal Earth projection, California is pushed off to the corner because this projection tries to take the curvature of the planet into account. So it's going to distort California slightly. As you can see, this is probably not a projection you should use unless you were working on a map that made sense to display curvature. If we're talking about the migration routes of whales, for example, that could make sense. Or if we are covering the Southwest and northern Mexico in a project, so maybe this could make sense, right? But you can see the limitations of the equal Earth projection. So let's go back to the Web Mercator for this one, which is the default projection when you open a map. Okay. There's one last projection I want to show you before we go on to other tools. So, for example, if I want to change the layout projection to a perspective as if I was looking from space, there is a specific projection that allows you to view the world from space, right? And that's it used to be called orthographic, but today it's just called the world from space. And this is a type of projection that could be useful if you want to insert a map showing a country of the world, a country or a region of the world if you were looking at it from space. And so it does take a bit to draw the whole Earth, but you can see that spherical. It alludes to the spherical shape of the Earth. The only downside of this projection is that this area here in the North Pole does not have the base map as well. Okay, So you have to work around editing that, adding an area to cover that bald spot, let's say, of the Earth, right? But this would be the a type of projection that you could use to display the world from space. Okay, let me go back to other projections. This projection usually makes the computer process quite a bit more. So we'll go back to the Web Mercator, which is a default. Okay, so far we have just been looking at changing the projection here for the map project, and this is how our map would display in a new layout. For example, if I created a new layout, let's say, since I'm going to ask you to do a landscape, a final landscape layout, let's add the new data frame of California. And so this data frame of California, let me activate. Let's close this. Format. Actually, I need to zoom out of this. So let me activate this and then just zoom out. Okay, so this is our layout. Let me now close that activation, and I could insert some text here where I would call this map of layout. I would call it California Mercator projection. Okay. All right, let me just save for now. Okay, let me go back to my map. Okay, so I accidentally closed the map that I was working on. So let me just say this. I accidentally closed this map because I have to reinsert the California shapefile. But so far we're here in the layout. Let's go back to our map. So in this layout, I would call this. I would label that Web Mercator, right? So here I could insert a text that says California projected Web Mercator, and let me insert a new map. And then here, what can do, let me right click, copy. If I can just paste here, there we go. So here I would also just change the color already. That way we don't get confused. So let's just choose something else. Let's stick to some of these colors. Sure, I'll do pink pastels for now. Right, and so that way here when we change this projection for California, let's do 983 state plane. Let's do UTM zone 11. So again, we see that slight slant for California. So in the layout, I could come once again and then insert a new map frame. And then here I would be using this California projection, right? Let me view this as a layout. So let me just zoom out slightly there, right? So you can see these smaller differences. Let me come back and then also let's create a new map. And then here, remember that we can always change the title here. So we could, for example, we'll click, just call this so that we don't get confused. California Mercator. For map 2, we could call this California ATM. And for map 4, here we're going to, I already copied the shapefile, so I'm just going to paste this. Let me also change the color so we have something different. Let's do this orange pastel. And so here I'm going to project California with, we already did the UTM zone, we already did the Mercator. So let's project California with the Albers. So here we're going to rename this map California, Alberts, right? And so we would do the same here. We would insert again a new frame that we are working on. So here we would insert our California Alberts frame. And again, like before, zoom out slightly. Okay, so you can arrange these as you go along, but the idea of this lab is to create a layout where you see California displayed in 4 different projections. Okay, so I will leave. So far we have done the Mercator, the UTM, and the Albers. It's up to you to choose the 4th projection that you want to use. Okay, but again, so far we have just been working here with California. If we come back and look at here we are again, our current coordinate system is Web Mercator for this one, right? So this is California Mercator. And then let me add a new map. And so this one does not have any data, right? And so the default is the Web Mercator. But let's add that California shapefile again that we have been working with. And remember that this California shapefile, it's the data that this shapefile has defined is in North American datum of 1983. Let's look at its spatial reference, right? So WGS 1984. Oh, excuse me, WGS 1984. That is the datum that we have as well for the data. Okay, so the datum for this shapefile is WGS 1984. If I wanted to change here for my data, if I want to change the coordinate system under which it's displaying, then I would have to use the project tool. The project tool is one of the most commonly used tools here under our toolboxes. This is projections and transformations. It comes out under the data management tools. So we also have projections and transformations. If you're working with raster data, we have the project raster. If we're working with vector data, we're just going to use the project, okay? And here we are going to, so for this 4th one, I'm just showing you how to use the project tool. So we would input the feature class that we have, which is the California counties. And if we want to project this feature class into a different coordinate system, then we're creating a new output item, right? So we're going to call this California counties, and let's say that we want to go from, the WGS 1984 Web Mercator to the UTM, right? So the output, I would look for the output coordinate system here. And if you already have it saved under favorites, so I already have UTM zone N, right? So notice how when I click on UTM zone 11N, we see the new coordinate system, okay? So again, notice that the datum is WGS 1984 for the Mercator, and notice that also the datum for the UTMs is also WGS 1984. So if I want to make this a projection from one datum to the other, from Mercator to UTM, we're using the same datum. So it does not ask me, or it does not suggest a geographic transformation because we have the same datum. But if I wanted to project from the Web Mercator, which relies on the WGS 1984 datum, and I wanted to project to the state plane coordinate system, the state plane coordinate system has a different datum as its basis, which is the North American datum of 1983. So what happens is that once you go from a projection that relies on WGS84 as its basis to, here we would rename this state plane, then notice that we're going from a WGS84 projection based to a North American datum. The state plane relies on the North American datum of 1983, which is an ellipsoid specific to North America. And here is where you deal with a transformation. Okay, so what is a transformation? A transformation basically is a method to convert data between two geographic coordinate systems or datum. And this parameter may be required if the input and output coordinate systems have different datums. And so there's a whole series of rules that the software already has for you, right? And so the default or the best choice is going to be the one that pops up. So the software is in charge of finding the best choice, but sometimes it's not the best choice. And so we can use these different, if I have, for example, if my North American datum state plane is in the Harn NAT83, then I would use something like this, for example, right? And remember that when you're going, if for example, I started with, if my California shapefile was in NAT83 state plane and I wanted to go to Mercator with the WGS84, then this could also work, right? So the transformation goes two ways. The good thing about the software is that it recommends to you the best fit, and you really have to get into the specifics if there are others that fit your transformation better, okay? Okay, so let's go ahead and run this projection. So here we are running the project tool, and we're going to have a new, we can get rid of this one. So let's take a look at the properties here. So here we have North American datum of 1983, state plane. State plane is our coordinate system, and our datum is NAT83. Okay, so this shapefile now has a datum of North American datum of 1983. Let's say that you get a shapefile, but you don't really know its projection, and this has happened probably several times for you, right? So let's just remove all of these, and I'm going to add a shapefile of the United States with its states plane zones, and if you notice here it says NAD 1983, okay? But let's add it. Let's add it. It says NAD 27, excuse me. U.S. state plate zones NAV 27 shapefile. Okay, so I add this shapefile, but we get this unknown coordinate system warning. This data source is missing coordinate system information, right? So click here to view details, right? So software update coordinate system. It says this following data source map is missing coordinate systems. Okay, yes, I know that because I purposefully removed the coordinate system. So if it's not here in North America, which is where the United States should be, then where is it? Let's zoom to the layer. Okay, so it's floating somewhere in space, or maybe somewhere in the middle of the ocean. And this has probably happened to you in the past, that you add some data and it's floating somewhere in space or in the ocean. This data doesn't have a projection defined, okay? So for me, what I did, I actually purposefully removed the projection file out of this shapefile. I took it out so that it would register with this error. Whenever you have a shapefile that does not have a projection and it's just floating in space, or it's floating in the middle of the ocean, you need to figure out what its correct projection is. So I already know that this shapefile is supposed to be projected in NAD 27. So when we run into this issue, we use a different tool. The project tool is when the shapefile already has a projection but you're going to switch from one projection to another, okay? The tool we would use for this job is the define projection tool. And so here is where you use the define projection tool when you know that this shapefile should be in a specific projection. So it says here nat27, so it should be a nat27, right? So let me input this US state plane zones. And so the coordinate system is unknown, but I happen to know it ahead of time. So then here I would just US state planes. So here let me go ahead and get it and find it. And then I could also type in North American datum. So then here it would take me to the different datums for North America territories. So I know it's in nat27. So then I would run this tool and I would define the projection, okay? So now let's click on zoom to layer and boom. So we're now in North America again, and this is the different state plane zones that we have. But the shapefile again is finally projected to North America. It's relying on the North American datum of 1927, and the projection for this data frame here is in Mercator, in the Mercator web projection as well, right? Okay, so that's it for this lab. Again, for this lab, you're going to turn in a layout showing California with 4 different projections. We already did Mercator, UTM, and California Albers. So for your fourth map, you can choose a different projection of California, add it to this layout, and submit that as a PDF. Okay. Thanks a lot. Sorry this took a little bit longer, but I wanted to make sure we went over the project tool, the define project tool, and the transformations options that you get when you are using these, okay? I hope that you found this useful and interesting, and make sure that if you ever find a data, for example, if you run into, if you find a map, for example, that is displaying data in an awkward way, maybe what you are seeing is the plate carré projection, right? The plate carré projection makes California look pretty squished, and this is the default for ArcGIS Desktop, is to display California in this square grid. And so if you import a shapefile that was defined or that was originally created in ArcGIS Desktop and California looks a little squished, then this is not a projection we recommend. And so the map of Illinois that we worked in the first tutorial, the first review tutorial, that shape of Illinois was a little bit squished as well. It would be squished here in this shape, right? Illinois is a bit larger north to south. So if you see a shape like this where the states look a little awkward, it's probably because they don't have the appropriate or more accurate projection, all right? And some of these projections, again, it's going to depend on the style that you want in order to get the map that you want as well for these projections. So here, let's look at. Let me just get rid of this, and then let's go back to our layout. And then so this could be, for example, my fourth. This could be my fourth projection here. So let me just center this, activate this. Okay. Okay. Close activation, right? So here we have California with 4 different projections. That's it for this project. If you have any questions, let me know. Send in the comments if you need help. But this should be a pretty easy tutorial to turn in, okay? Have a good week.